Hello students, in this video we'll discuss the disk method for finding the volume of revolution about an axis. If we're given a function y equals f of x over an interval a, b, we can find the volume of revolution obtained by rotating the function y equals f of x about a line L. So our general problem is to say, we'll do a simplified version of this. We can make this more complicated. If we're given a function, say this is my function, say this is my point A and that was my point B, and then I had a function like this, y equals f of x, there's our function, there's our interval. And let's say I want to take this function and rotate it around a line. I could do that. Now, of course, you can imagine getting many different shapes. What I could do to make the problem easy is I could say, let me just rotate this around the x-axis. And so let's see what would happen. I would pick up this point over here, and rotating it around the x-axis would form what kind of shape? It would go back over here, and then up like this. So you get a circle if you rotate that one particular point over the x-axis. So imagine picking up a point and rotating it around the x-axis. That would give you a circle. I can do this for every single point on this curve. And so what we'll end up getting is we'll get a shape that looks like this. And we've formed a volume. And so our question is now, what is the volume of this region? And what we'll do is we'll say, we have a very good way of doing this. We can say our answer is that we recall the volume of a cylinder. So let's draw a little cylinder over here. The volume of this cylinder is going to be, if this circle has a radius r and this is the height, then the volume of this volume is going to be pi r squared. That's the area of the circle times h, the height of the cylinder. And so what we're going to do over here is we're going to say, OK, let's take our volume over here, and we're going to do our standard calculus thing. We'll take this region, there's the x-axis, there's the y-axis. I'm going to take my function over here, something like maybe looks like this. Basically, this is an abstract function. There's a, there's b, and I'm going to break up this interval into really small subintervals of length delta x. And what we'll do now is we'll say, let me look at this. What we'll have over here is on this interval, so this is x1, x2, etc., up to xn, then I'm going to try to find the volume of, if I take this little strip over here on the interval xi to xi plus 1 and rotate that, so the xi to xi plus 1 strip is going to look something like this approximately. It's going to be this really thin cylinder. And so the volume of this really thin cylinder is going to be the function's height at one of those endpoints. You can pick either one because they're very close by continuity. So it'll be pi, and then the radius of this cylinder will be the function's height. So this will be f of xi squared. And then the height is just going to be a delta x. And so if I add all of these up, the volume of revolution will be approximately the sum, j goes from 1 to n, of pi f of xj quantity squared times delta x. And this, of course, is a Riemann sum. And as n goes to infinity, we see that the volume of revolution is going to be pi, the integral from a to b of f of x squared dx. And so this formula over here is the formula for finding the volume of revolution for rotating the function y equals f of x about the x-axis in between the points a and b. If we have a different axis of revolution, we can adjust this argument accordingly, as we'll see in further videos. But for the time being, this is the disk method for finding the volume of revolution. If I give you a function and I rotate about the x-axis, you integrate that function from a to b, pi times the function squared dx will give you the volume. Thank you very much.